We have one question from the chapter Similar Triangles. The question says Rohan is a very intelligent in mathematics and he always tried to correlate the concept of maths in daily life. One day he was walking away from the base of the lamp at a speed of 1 meter per second. So you can see there is a figure and he is moving away from the lamp post. That means in this direction he's moving with a speed of 1 meter per second. And the height of the lamppost is also given, like this height is mentioned as 4.5 meter. So we have this as 4.5 meter. And we have to find what is the case. Now, the question is here, after 2 seconds, the length of the shadow is 1 meter. What is the height of the Rohan? So this length, that is length of the shadow is this, right? This we are given mentioned here as this shadow is 1 meter. 1 meter, as you know that the shadow length will keep changing as our relative distance with the source of light changes. So after 2 seconds, that means let's figure out how much is the length of BD. So we know that distance is equal to speed into time. So that means BD is the distance and the speed is 1 and the time is 2 seconds. So it's 2 meter. So we can say this distance is 2 meter. Now we have to get the length of CD here, as we have this CD is what we have to get. For that, I'm going to use the concept of similarity. I'm going to prove the triangle similar. Now, you know that this angle is common and these are standing vertically to the ground. So it will be 90 degree. So we can say that triangles are similar. And the order of correspondence will be what? Triangle A, B, point is not mentioned. So let's L, or let's take some other point, say P. ABP is similar to triangle CDP because A corresponds to C and B corresponds to D. Now, if it is done, we can write the sides being proportional, that is AB over CD. As you know, CD is what we have to determine. So AB over CD is, so the DP here is 1. So now if I do cross multiplication, we say CD is equal to 4.5 divided by 3, that should give you 1.5 meter. So we got the length of or the height of Rohan as it is 1.5 meter. Now let's see the next part. In the next part, the question is what is the minimum time after which the shadow will become larger than the original height? So when this shadow will become longer than this. And we have to determine the time. So let's erase the information which is not valid for this question, except for CD. I don't think we need anything. The proportionality is needed. The remaining is not needed. Now let's understand what they are asking. Actually, we have to find the time on which. So time, as you can see, the speed is 1 meter per second. So let the required time is y seconds, after which. So we know that distance is equal to speed and time. And since we can see that speed is unity here, so that is 1 multiplied by any number is number. So distance will be y only. So I assume that after y seconds, so after y second, he will be covering this y meter, right? Y seconds. So it's because the speed is 1. That's why the time and distance will be same. And we are considering, let's first consider when it will be equal, and then only we can see when it will be bigger. So as of now, the height of the Rohan is 1.5, and let's say after y seconds, its height is equal to the shadow, or the shadow is equal to height of Rohan. So from here, what you can see, we can get some measurements. Let's say AB, I'm replacing AB with its value 1.5. CD is 1.5, that is 4.5 over 1.5. BP, B2P is what? Y plus 1.5, and DP is 1.5. So we can cancel this and we conclude from here that y is 4.5 minus 1.5 is 3. Well, if you write y as 3 meter, and the time is same. So that is after 3 seconds, right? So the minimum time is 3 seconds. By that, we mean to say that at 3 seconds, its height will be equal to or the shadow will be equal to the height, and there onwards, the height will be bigger. Now, in the next part, what is the distance of Rohan from the pole at that point? Distance of Rohan from the pole, that means y only. So this is also 3 meters. We have one more. What will be the length of the shadow after 4 seconds? So that's a different question. So we have to erase the other informations written on the. Okay. Now question is, what will be the length of the shadow after 4 seconds? So after 4 seconds, we can find out the distance. And I believe I can erase these things. Okay, so once again, using the same information, that is distance is equal to speed into time, I can say distance is, we are looking for distance, which is speed, which is 1 mentioned here, and the time is 4 seconds. You can say distance is equal to 4 meters. So we have to take this as 4 meters, and we have to find out the this distance, that is dp. So I can take it as x for working. I can take this as x. Now, once again, using the same proportionality, here, we can see that we have AB in this figure will remain same, 4.5 being fixed. CD is the height of the Rohan, which also is fixed. DP is what we have taken as 4 as per the question, and this is going to be x plus 4, that is BP. So I can reduce this by 3 times, and by cross multiplication, it's going to be what? 3x plus 12. Like I'm multiplying this with this is equal to, we did some mistake. Yeah, the order in which we have written is wrong, right? So this is BP first. So BP should have been BP is x plus 4 over dp, that is x. If you do cross multiplication, or before that, we can reduce. So this comes out to be 3 into x is equal to x plus 4. So 3x minus x is 2x is equal to 4. That is x is equal to, once again, 3x minus 2x, yeah. And this is 4 is equal to, x is equal to 4 by 2, that is 2. So we say that the shadow will be 2 meters after 4 seconds.